Hi, I'm Eric Lanask here in Santa Clara at Editor's Day. With me on the program today, Suhail Dhanani from Maxim Integrated. Suhail, thanks for joining me.
Thank you.
So why not start off, tell me, who is Maxim Integrated?
So Maxim Integrated is one of the leading suppliers of analog and mixed signal products. We are about a $2.3 billion corporation with about 9,000 employees based right here in San Jose. And we are the worldwide suppliers of all kinds of analog chips. And a majority of our analog chips are used in industrial, healthcare, consumer, and other applications. So I come from the industrial and healthcare business unit, and I'm here to talk about the trends as far as industrial market segment goes.
Okay, so what are some of the trends that you're seeing in the industrial space?
Well, the single biggest overarching trend, I would say, is the development of what we call industrial Internet of Things. Mm-hmm. Now, I know Internet of Things is a big, hyped word, and largely it refers to the consumer IoT, which means something like connected cars, connected homes, wearables. Mm-hmm. But what we believe is the real application of IoT will be in the industrial segment, where you connect up sensors and machines that run your factories, run your coal mines, your oil and natural gas installations, primarily things that contribute about 2/3 of the world's economy. And we think the single biggest impact, both in terms of business and socioeconomic, will be from the industrial IoT as opposed to the commercial IoT.
Interesting. So how did some of the architectures that you're dealing with change when it comes to industrial IoT?
So Maxim chips are largely used in all the industrial automation equipment. And as you know, factories are getting automated more and more.
Sure.
So as you want to connect these factories up to the internet, you realize that you have to change the automation system architectures. And Maxim gets a very nice perspective on this because we are the guys they call when they want to redesign their system. So we get a great perspective from our worldwide automation equipment vendors. So what we are seeing is, and I can boil it down to basically two big trends in terms of system architectures. One is we see a pervasive sensors, which means sensors everywhere in factories, in oil fields, in coal mines, and all these places. And these are intelligent sensors, so what I call pervasive intelligent sensing. So these are sensors which are small, which are intelligent, which collect meaningful operational data so that people can actually use that data to optimize their operations. The second thing I see is the development of small distributed controllers. Instead of one controller sitting around in the corner of the factory, we have multiple distributed controllers which are connected all up to a central internet, but they are also controlling the different sub-assemblies of the factory. And that's what we see, the development of small distributed controllers as well as sensing.
Are there specific industry segments or markets that you see driving these trends that you've talked about around industrial IoT?
Yeah, we see mostly across the board, but I would say things like machine builders are first in line just because they're so close to it.
Sure.
We see a need in process industries, which would mean oil, natural gas, wastewater, just because there is a need to control and make sure nothing goes wrong. So it's much more easier to justify throwing a bunch of automation equipment to make sure there are no mishaps, shall we say, on these things. But overall, we are seeing this across the board. We even see this in the innovative car industries like the newer EV cars, where the new fabrication facilities are completely automated. Now, this also affects us in a certain way, Maxim, because we have to develop the technologies that enable these kind of sensors, that enable these kind of controllers. Because you cannot just do this by an incremental, by making it incrementally better. You have to make it by actually rethinking the architecture of the systems.
So talk to me a little more specifically about some of the ways that you've started to develop and enhance your products as a result of these trends.
So let me kind of start out with the top level thing, and I'll show you this. This is what is known in the industry as a micro PLC. PLC stands for Programmable Logic Controllers. Now these used to be the size of a cabinet, and now you can hold one in your hand. Now how is this enabled really? Just not by incrementally optimizing the design. You have to rethink the entire architecture. And this little thing has about 50 Maxim ICs. They range from power, transceivers, signal conditioning, processing, everything. So it's a combination of all of Maxim's technologies have come together to create something which can sit in the palm of your hand and yet control a small size factory. Now, this PLC is a technology demonstration platform. Maxim by no means is in the PLC business, but we build this to show people what is possible if you take the right analog integration technologies. So this is an example of that. The second example I have for you are sensors. Now, we think of sensors as fairly large devices, but this is the next generation sensors, and I don't know if this is the right way to see this. This is a proximity sensor developed using Maxim technologies, enabled by a new I/O standard called IO-Link. So Maxim right now is one of the leaders in the IO-Link transceiver technologies, and what it does is allows you to build small, power-efficient sensors that actually communicate useful operational data over the IO-Link standard. So the sensor won't even tell you, just doesn't tell you if it's on or off. It tells you how many meters it's far away. So you have some data to use in the industrial IoT.
Impressive. So aside, obviously, scaling down in size is huge. What are some of the other challenges that you're seeing some of your customers facing, and how does that impact what you have to do? How are you helping them overcome those?
One very classic example is when you scale something down to this size, there is, as you notice, there's no fan.
Right.
So this thing has to work flat out without any kind of cooling. So one of the things that Maxim is very focused on is extremely high power efficiency, because you cannot dissipate heat. There is nothing to dissipate it away from. So you just don't generate enough heat. So a lot of our power products, for example, we think we have the widest range of power products that work at 90% conversion efficiency. And so what it does, it dissipates extremely less heat, almost half of what it used to do about a few years ago. And that helps pack so much electronics in one thing without the need for a big fan taking away the cooling. So that's not only the form factor, but the power efficiency is a big factor in these things.
Very interesting. That really gives whole new meaning to the idea that the saying that he's got the whole world in his hands.
We got the factory controller sitting in my hands. Yeah.
That's fantastic, Suhail. Certainly look forward to seeing more of the innovation from Maxim Integrated. Thank you so much for being on the program with us.
Thank you. Thank you for getting me in.
At Editor's Day.